Okay, for today, I'm going to be working questions 41 through 44. So let's see. First of all, it says CF, the segment CF is perpendicular to the segment AD. So the ray CF is perpendicular to the segment AD. What does that mean? Perpendicular. They cross a 90 degrees. So let me see what we're looking at here. I see here's the ray CF. Here's the segment AD. They're perpendicular, so that means they cross a 90 degrees. 90 degrees on each side. So the measurement of one side is equal to the measurement on the other side. Right? Those two angles are equal. That's basically what it means. They're 90 degrees on each side. Okay, let's continue reading. So angle ECF is congruent to angle FCG. So ECF, that's basically this angle, is congruent to FCG, that angle. So I'm pretty much going to agree that this angle is equal to this other angle, right? I can agree on that. Find the area of triangle ACE. Okay, another thing I want to see here, another thing I want to see is that I can agree that this angle here is 90 degrees because I see that AD and BC, they cross on 90 degrees. I mean, AD and BE across on 90 degrees. There was the 90 degree here. So then I can say the other one's 90 degrees. I can take a look at two triangles. Let me take a look at two triangles here. By angle, I'm saying angle, so I'm saying there's a pair of congruent angles. There's a second pair of congruent angles. So the two angles on one triangle are equal to two angles on other triangle. So by angle, those two triangles are similar. Okay. So based on that, I can find the value here. I can find that value based on that. Okay. For right now, let me call it X. I'm going to find the value. So let me write X equals. Keep in mind, this is not what I'm solving here. I need this side, the side that I'm asking here. I need this side for later. So I'm just going to solve for this. I know those two triangles are similar. So from the little triangle, I'm going to use the measurements 8 and 8. From the bigger triangle, I'm going to use the measurements 8 and X. If I cross multiply, 8 times X is equal to 64. Divide both sides by 8. So X is equal to 8. Okay, I can find this side. This, by the way, this drawing is not drawn to scale, okay? So let me erase these things. Again, I found this blue side is 8. I'm gonna need it in a minute. Okay, now here, find the area of triangle ACE. Let me highlight which one is triangle ACE. Find the area of the triangle ACE. Round to 2 decimal places if necessary. Okay. If we know how to use what's the area of a triangle here, let's just go at it, type it in. But some of us might not remember how to get the area of a triangle. Let me just do a quick review how to get the area of a triangle. Let's just say I have a rectangle. And let's say our rectangle, it's, make an example up here. Let's say 5 by 8. It's a 5 by 8 rectangle. What's the area of the rectangle? Well, 5 times 8 gives me 40. So the area of that rectangle will be 40. But the cool thing is that I can cut my rectangle in half. So my 40, I break it in 20, right? Because I cut it in half. Remember, the whole rectangle was was 40, so the half of it should be 20. Again, I'm doing a separate example to review what's the formula for area of a triangle. But the interesting part is that half of a rectangle gives me a triangle. And for me to come out with the formula for this 20, in reality, I went 5 times 8. I know there's a 90-degree corner here. So what I did was I multiplied. I multiplied the two measurements across a 90 degrees, and then my result, I divided by 2. That's really what we did, right? 5 times 8 gave us the whole rectangle, but then I cut it in half, so that means we divided by 2, and that's how we got the 20. So how are you going to solve here question number 41? Well, I had to multiply the two measurements across a 90 degrees for this triangle, which are going to be 11 times 8. Where did I get the 11? Here. 3 plus 8, right? That's one of the sides of the right. I'm looking again at the 90-degree angle. What are the two sides that make the 90-degree angle? One side is 11. The other side is here, 8. So I have to go 11 times 8. And then my result, I'm going to divide it by 2. I can type in a fraction. I can type it in on my calculator, right? I gave you guys a website to use that calculator if necessary. So I know 11 times 8 is 88, divided by 2 is 44. There you go. That's the area for that triangle. Let's take a look at number 42. CF is perpendicular to AD. So the ray CF is perpendicular to AD. Okay, so we're going to use what we just did in 41. Let me jump in to say that this little triangle, this yellow triangle, and this green triangle are going to be similar, right? We just proved it on the previous question. I see CF is perpendicular to AD, and the angles ECF is congruent to angle FCG. So we just know that this second angle is equal to this second angle, and then the corner angles are 90. So, okay. Again, like I did earlier, let me solve for the side BE, because I'm going to need it. I'm going to need it. For right now, let me call it X, right? Because I don't know the value. X equals something. So I'm just going to say, okay, from the little triangle here, the yellow triangle, I'm going to use the values 5 and 7. 5, which is the altitude, 5 is corresponding with X, and 7 is corresponding with 12. Might be like, how do you know if 5 goes with X or 5 goes to 12? Look, the 7 is in between the two angles that are marked, right? The 12 is in between the two angles that we marked. So 7 and 12 are corresponding. So that means 5 and X are corresponding. Okay, now let me cross multiply. 7 times X is 7X. 12 times 5 is 60. Let me divide both sides by 7. And I'm going to say X is equal to 60 over 7. I don't want to deal with decimals right now. I might deal with it later, but I don't want to deal with decimals right now. Just 60 over 7. My calculator says like 8.5714. I don't want to deal with decimals. Okay. So this blue side is 60 over 7. Okay. Now, the question here is find the area of the triangle ACE. So I'm really looking at this whole triangle here. I know this side right here is 18. And then this other side right here is 60 over 7. So I know I have to go 18 times 60 over 7. And all this divided by 2. literally gonna type this on my calculator. Let me open my calculator that I gave you guys on Canvas. Literally gonna type it in like that. Okay, so this is the calculator that we have. So I'm just gonna type it in how we need it. So I know I need to type in a fraction. On top of the fraction, I'm typing in 18 times another fraction. I have 60 over 7 and all this over 2, right? That's basically what I needed to type. On the top, I have 18 times 60 over 7. At the bottom, I have 2. I'll even press enter. Now there, I see my answer, 77.1428, a bunch of numbers. I'm going to round it to 2 decimal places. So I see my first 3 decimal places are 77.142. Okay. So just a little reminder how we round up, or how we round, not up, round to the nearest decimal, 2 decimal places. On our calculator, we saw 77.142. My third decimal number is small. 4 or less is small. This one's small, so we ignore it. So my answer is 77.14. Okay. I said I'm working up until 44, so let me flip the page. Let me move on to number 43. So the segment FH is parallel to IJ. So this side is parallel to this side. Find the perimeter of triangle FGH and round it to 2 decimal places. Well, because these are parallel, these angles are equal. Angle G, or JGI, is congruent to angle HGF. So that means that, let me see it as triangles. You guys see a little triangle here? This triangle is similar to this triangle. Okay, so you guys might be wondering, well, why do I need that? Why do I need that to find the perimeter of this triangle? Could I just be adding the sides? Yeah, we could if we knew them. But look, part of the triangle is 16th, part of the triangle is 11, part of the triangle here I see 13, part of the triangle is 4, but we don't know this part. So because of that little part, right now I don't know it, so let me call it X. I'm going to use similarity to be able to solve for it. From the little triangle, let me call segments, let me call them like red triangle and blue triangle like I've been calling them. So let's call this the blue triangle. The little triangle, I usually call it blue. Oh, let me change this to blue. Right, this is part of this thing. I don't know what the value is. I'm just going to say X equals. I call it X because when I don't know the value of something, I just replace it with the letter. So I'm going to say the little triangle, I'm going to use the measurements X and 4. From the big triangle, I'm going to call it red triangle. I'm going to use the sides. I know X is corresponding with X plus 11. So I'm looking at this whole side, X plus 11. And then for 4, I'm looking at this whole side. I'm going to call it 4 is corresponding with 17, right? Because 13 plus 4 gave me 17. Okay, I got to solve for X here. So let me cross multiply 17 times x is 17x. Now here, 4 times x and 4 times 11 will give me 4x plus 44. Let me subtract a 4. Right, I moved it to the other side. I changed the sign. I know 17 minus 4 is 13. So I have that 13 times x is equal to 44. So it means that x is equal to 44 divided by 13. I don't want to deal with decimals yet. 44 divided by 13. So now for my perimeter, I'm going to go, I have to add all my sides, right? I know this side is 44 plus 13 plus 11 plus 16 plus 13 and then plus 4. So I'm really gonna, that's what I'm gonna write here. 44 over 13 plus 11 plus 16 plus 13 plus 4. Okay, so 44 over 13 plus 11 plus 16 plus 13 plus 4. Use your calculator. So we had 44 over 13, right? I'm keeping that as a fraction, plus 11 plus 16 plus 13 plus 4. Press enter. It gives me 47.384. I'm going to round it to 2 decimal places. So 47.384. I'm going to call it 47.38. It's about 47.38. Not bad. Let's take a look at here. Number 44. Find the perimeter of triangle VWX and round to 2 decimal places. Right, VX is parallel to YZ. So I know that kind of like we did in number 43, a little triangle is similar to a big triangle. I want to solve for this side. I'm going to call it X right now. I'm going to say X equals, it has to equal something. Okay, so from the little triangle, I'm going to use the values X and 4. From the big triangle, this side right here is X plus 9. This other side right here from V to W is 14, right? Because 10 plus 4. And then obviously there's the third side I don't need. Okay, cool. Let's cross multiply. 14 times X gives me 14X. Now here, 4 times X and 4 times 9 gives me 4X plus 36, right? It has the plus in between, so 4X plus 36. My 4X, let me move it over. I know 14 minus 4 is 10. So I have that 10x is equal to 36. Let me divide both sides by 10. Now 36 divided by 10, it is a decimal. It is not a long decimal. It is just 3.6. I think, even though I don't like dealing with decimals that much, 3.6 is not bad. Right, so I'm just going to call it 3.6. You don't want to deal with decimals yet, call it 36 over 10. And then on our calculator, we're going to add 3.6 plus 9, because I'm adding all the sides, plus 18, plus 10, and then plus 4. I said I'm adding all the sides because that's what perimeter is. My perimeter is 44.6. You could have said, well, Mr. Leonzo, why didn't you just give me that 3.6 to begin with? So I just added the sides. Yeah, because perimeter of a triangle, that's what, like pre-algebra? You guys saw that in what, middle school? Yeah, perimeter, just adding the sides, you know how to do that. What I really want you to do is use similarity, use similarity to find a missing part, and then just add all the sides.